Hey guys, today we're going to look at weather. We're going to start to get into it, and we're going to start with the difference between weather and climate. So, first question is, what is weather? Weather is a very local thing. It's short term. And what does that mean? That means if you've ever been outside, maybe in an open field on a cloudy day, maybe it's not raining right above you, but you look across the field and you could see like a big sheet of rain heading your way. So maybe just a few blocks away, it's raining, and where you are, it's not raining yet. And the other thing is, so that would mean local. The other thing is short term. You could have sun out, and then 10 minutes later, it could be cloudy and pouring. So weather is very, very local and short-term changes in our conditions in the atmosphere. Climate is the long-term weather pattern of a region. So think here in New York, we're in May, heading towards June. We kind of know the pattern here, right? We're heading towards summer. We know it's going to get hotter over the summer months. Then once September hits, it starts to get cooler. Once November, December, and January hit, we're in winter. It's cold. So climate is that long-term weather pattern. So another thing to know is, what is the main source of energy in our atmosphere? That is water vapor. Yesterday we took a look at page 14 of the reference table. We looked at the three graphs in our atmosphere, and we saw that one of those graphs was water vapor. And the only layer of the atmosphere that has water vapor is the troposphere. That's where we live. Without water vapor, we wouldn't get clouds, we wouldn't get rain, we wouldn't have weather. So if they ever ask you what's the main source of energy for our atmosphere or what causes weather, it is water vapor. And water vapor is pretty much in only one layer of the atmosphere, the troposphere. A couple of other things, meteorologists. Yes, those are scientists who study weather. All right, good people, by the way, really good people. Okay, so when we're looking at weather, we're going to break it down for variables. And this is kind of how we're going to start off the topic of weather. So the first variable is temperature. And if you think to yourself, what else do I hear when I'm listening to a weather forecast? Well, always the first thing, pretty much always, they'll mention temperature. Then another thing they'll mention is humidity. That's telling you how much water vapor is actually in the air. If there's a lot of water vapor in the air, you have high humidity, you would probably have clouds and close to rain. Air pressure, we'll talk about that in detail on the next lesson, but air pressure basically tells you whether the weather is going to be good or bad. We'll get into that in further detail, like I said, the next lesson. And wind. These are the four variables we always hear about. So we're going to break it down. We're going to start with temperature. We'll do that today. So what is temperature? What causes air temperature to occur in our atmosphere? It's the measure of the average kinetic energy of air in the atmosphere at a given place and time. So what does that actually mean? Well, kinetic energy is energy of motion. So if the molecules are moving a lot and very quickly in the atmosphere, they're probably going to collide, hit into each other. And when that happens, you get friction. And that means the more kinetic energy in the atmosphere, the more friction, the more heat. So higher average kinetic energy would cause hotter temperatures. So what about temperature? Temperature actually changes on a daily cycle. As you know, one day it could be 60 degrees. The next day here, it could be 40 degrees. So things change every day. Could change within a day. It also depends on how much sunlight's getting through. We talked about insolation, incoming solar radiation. On a cloudy day, you have less sunlight. That usually means cooler weather. So the duration, the angle of insolation, remember we talked about that too in the last topic. If you have a longer amount of sunlight, It's heating up our atmosphere more. The longest amount of sunlight we have is in the summer. We also have the highest angle of insolation in the summer. So when these two go up, the duration and the angle of insolation, that happens in the summer, that would cause hotter weather. Cloud cover, I just talked about, the reflection of the sun's rays, less cloud cover, more sunlight, hotter temperatures. Now I put this up on the PowerPoint as well. Reason being, if you're asked to convert temperatures, we already went over this, but I just wanted to remind you, this is on page 13 of the reference table. You will have to do some temperature conversion problems, not in tonight's homework, but in Monday's homework. Okay, so what about air temperature? Two cycles that dominate our weather. The daily weather cycle, which I already talked about. Actually, I didn't really talk about it. So normally in the morning, we start off cool at sunrise, and then the sun rises in the sky throughout the day. You get a higher angle of insolation, and we heat up. And then at night, the sun sets. We have no sunlight. It gets cool. So the hottest time of day, as we talked about in the last topic, is during the afternoon. The coolest time is overnight and around, or actually around sunrise, early in the morning. And then the seasons which are caused by the tilt of Earth's axis. And we know that the warmest season here is summer, and the coldest is in winter. So, I already went over that. And one other thing I wanted to mention. On a clear night, you're going to get the coolest night. A cloudy night is actually usually a warmer night. And the reason is, if you remember, we talked about how the sun's energy works, right? So here's the sun, and remember, the sun gives those UV rays going down, the short wavelengths coming down from the sun. They hit the ground. I'm going to make this the ground right here. And the ground is a good absorber. It'll absorb the sun's energy for hours, and then eventually re-radiates back to space. And most of that happens at night. But if it's a cloudy night, the clouds will cause the heat to get trapped here on Earth. And that is why those infrared rays at night on a cloudy night will cause a warmer night. I'm just running over this real fast. Now, when we are trying to map out the weather, we're going to start getting into mapping. And you should have a background on this. Now, this is just kind of a predicted temperature chart, but it's based on color here, which I'm going to have difficulty with. But you could kind of see the temperature kind of runs east to west. So we're going to draw isolines to show what the temperatures look like overall in a large area, in this case, our country. So the lines of equal temperature are called isotherms on our map. So I'm just going to kind of do this, and you kind of see I highlighted that line between, I'm thinking that's yellow, and that is orange, but I'm not really sure. But it looks like if I was to match the temperature, it looks like this here is right here, and this is right there. So this actually represents the 60-degree line. So I'm going to draw another line that separates this color from that, which would be right, where is that? Right here. That would be our 70-degree line. Notice as I go south, the temperature goes up because I'm getting closer to the equator. We know our coldest temperatures are to the north as we go near Canada. So why does this help on a map? I want you to think back to topographic maps. If I was to put a point, let's say I was to put a point in here. I'm going to change this pen color to black. If I was to put a point right here, you could tell me that the temperature here is somewhere between 60 and 70 degrees, just like when we did the topographic maps at the beginning of the year. This could be 61, 62, 63, all the way up to 69 degrees. If I had a point right on this line, that would be 70 degrees. A point right on this line would be 60 degrees. So That's not what you're going to have to do, though. You're going to have to do something like this. You're going to have to draw isotherms, lines of equal temperature on weather maps, and they go in 10-degree intervals. Like on the last map we just saw, I drew a line for 60, then I drew a line for 70. So every line's going to go up 10 degrees on our weather maps when we're talking about temperature. So how would I do this? Well, here's how I will do this. I always look to see, I'll go to the north, and we're going in 10-degree intervals. So I want to hit the lowest number that is divisible by 10. Looks to me like that's 50. Now, I see another 50 here. So I know these 2 points are going to have to connect. And then I see a 60 down here. So notice the temperature is going up. So knowing that the warmest temperatures are to the south in our country, because they're going toward the equator, right? We get closer to the equator as we go south. I'm going to start drawing my line, and then I got to keep that 53 to the south of my line like that. There's another 50, and there's a 59. Whoops. That was a mistake. I ran out of room. Whoops, it should look like that. That should be like a straight line. So you see that's my 50-degree line, and notice warmer temperatures are to the south of my 50-degree line. 53 is warmer than 50. And you want to mark what that line represents. That's 50. So I'm going by 10-degree intervals. My next line will be 60. So I find a 60 here, I find a 60 here. Here's a 59, here's a 62. So I'll start here, and I know my 60 has to go in between 59 and 62. I hit my 60, and see 63 is just south of my line. Here's another 60. I know 60 goes in between this 53 and 70, and right there. And wait, got to go up, right? Because 62 is warmer than 60, and boom. That would be my 60-degree line. I want to represent it. And here's how I'm going to check that I got it right. Is 59 in between 50 and 60? Yes. Is 53 in between 50 and 60? Yes. So these two lines look pretty good so far. Going up by 10s. Now I want to start at 70. I don't see a 70 out here. But what I do know is that 70 goes in between 65 and 71. So I know my 70 line is going to kind of go like this. Now I see a 70. Notice warmer temperatures to the south, colder to the north of that line. 70 goes in between 62 and 70. I don't know if that's 75 or 73. Doesn't really matter. 70 goes in between 62 and 79. So I'm going to keep making it. And look, I hit another 70. 70 went in between 60 and 79. 70 goes in between these two numbers, 63 and 75. 70 goes in between 60 and 75. It goes in between 66 and 75. And look, I hit another 70. And now I can bring that there and represent my 70 line. And again, I could check. Look, here's the 60 line. Here's the 70 line. Notice all of these numbers are in between 60 and 70. Let's go to the 80 line. I'll start out in the west again. Here's an 80. Here's my 70 line. So if I do this and I make this my 80 line, notice these temperatures are in between 70, 80. I'm on a good path here. 75, 83. Looks like 80 will go in between those two. Here's another 80. 70 and 84. Go slow, and you want to do this in pencil, by the way. All right. 80 is going to go in between 75 and 84. Wait. Oh, here's a tricky one. 81, 75. 80 goes in between those two numbers, right? 70 and 86. 80 will go in between those. And 82 is warmer, so it goes to the south. Again, I'm going to make my check. Just check. All of these numbers in here should be in between 70 and 80, and looks good. And I'll go one more line, the 90 line. Here we go, 90, 90, 90. This is kind of easy right here. This 90 line is going to be real easy. Oops, just got to take my time here. 86, 91, and my 90 line. Boom, 90. And look, aren't all these numbers in between 80 and 90?